Hello everyone, this is Dr. Rajesh, and today I am with you with the topic which is Introduction to Operators. So in this topic we will study various kind of uh, operators that are used in numerical analysis. So interpolation depends upon the concept of operators. What is interpolation? Like if we say that we are given this is a line, okay, and we are given the set of points upon this line, okay, and say this is x-axis, okay, and some function fx is defined upon it, and it has some values, say at this is x naught, this is x1, and so on. So these are the points, and value over here is f of x naught, here is f of x1, and here is f of x2, and so on. So what is interpolation? Now try to understand the concept of interpolation. If we are required to find the value of the function at any intermediate point, and say we continue something like that, continue, and here is point, last point, say this point is xn. So it is set of n plus 1 points, and we are asked to find the value of the function at any intermediate point. Say this is the point where we are required to find the value. So we are required to find the value when the value of the function fx is given at x0, x1, x2, x3, x4, and up to xn. So that way these values of fx are given, and function as such is not given. If some function is given, like if we are given some function, say f of x is equal to x square, then we can easily find the value of f at any point. But in this case we are not given any function, but some n plus 1 values of the function are given at n plus 1 points, and then we are asked to find the value at any other intermediate point. So that is what you call as interpolation. Inter means in between the given set of values. So in this, function is unknown, you don't know the function. So that is the importance of your interpolation, and that is you call as a interpolation. So now next we move towards the operators, different kinds of operators. So let me rub it, then we will be moving towards the different kinds of operators. Now see what are the different kind of operators. Here first is forward difference operator. So forward difference operator is denoted by symbol delta. and its formula is given by delta f of x is equal to f of x plus h minus fx. So this is the formula for forward difference. Here is the difference between two numbers, so here difference in its name. Now why forward? Because since this is x plus h, this is x minus h, and it is taken in the forward direction, so the difference is from this quantity is in the forward direction with respect to x, so hence the name forward difference. So this is the operator denoted by delta fx is equal to fx plus h minus fx. So this is the forward difference operator. Now next is backward difference operator. So this is will again be difference, so it is denoted by the symbol, this one. This is something upside down of delta, and this is known as nebula. So this symbol is known as nebula. So and the formula for backward difference is given by, this is also called del. If I say this is also called del, you may also call it as a del. So in future if I say del fx, it obviously means symbol nebula. So this del fx is equal to fx minus h. So now why it is backward? Because now in the earlier case it was in the forward direction, this was taken, but now backward to this x is x minus h. So this will be fx minus the backward value of f at backward quantity x minus h. So this will be backward to this one, so that is why it is called backward difference operator, because it is in the backward direction with respect to x. So this is called backward difference operator, and it is denoted by nebula, or it is also called a del fx is equal to fx minus h. Now next, this will be the third shift operator we will be studying. And what do you mean by shift operator? Shift means shifting to the next adjacent value in order, consecutive next value to the given value, and that is what we call it as shift. So it is denoted by capital E, and the formula is this one, en. If shift operator is applied n times, this will give the result f of x plus nh. If n is equal to 1, then e1 is equal to f of x plus h. So once again I will show you why it is called shift operator. Let us say this is the line and this is x, this is x plus h. So see, this is the shift from x to the next adjacent value in the forward direction. This is the shift operator. So this is x is shifted to x plus h. When e is applied to f of x, it gives the value of f at x plus h, and if it is applied n times, if it will be applied 2 times, here will be next, it will be something like 2h. If it will be applied 3 times, it will be 3, and if it will be applied n times, it will be nh. So this is the shift operator. if for two case, if I show you, if here is e is square and this is f of x, so how will you write it down? You will write it down something like e, here is e, and this is applied upon f of x, and this bracket closes. So by this one, this is equal to f of x plus h, so this will be e, and this will be f of x plus h. Both bracket closes. Now once again e will be applied, the result will be one more increment, it will be one next increment, say this is x, and it will be 2 h. So now it will be f of x plus h, it will be 2 h. So simple generalization will induce this result, that when it is applied n times, when it is applied 2 times it gives here 2, when it will be applied n times, simple induction will give the result this one. So this is the shift operator. And now look at its name. Shift means it has shifted x to x plus h and x plus h to x plus 2h. So every time it is being applied, let us say if I applied here e, this shifts. If I apply again here e, this shifts. So every time it shifts in the forward direction. So this is the shift operator. Okay, so now we will move towards the central difference operator. Now what is, let me first rub this one. Central difference operator is denoted by delta, which is also known as small delta. This is small delta, and earlier we used that one for the forward difference operator. This one is known as capital delta. This is capital delta. So this is capital delta. This one is capital delta. And formula for central difference operator is given by this is small delta of x, this is f of x plus h by 2 minus f of x minus h by 2. So this is the formula for central difference operator. This is the operator and this is the operand. So why this formula? This formula because this is in the center and the difference is between these two quantities. One is the right to the center and one is to the left to the center. So and this is in between, exactly in between. So this and this difference is called central difference operator. So this is the formula for central difference operator. Now if we write it in the sense f of x plus h is equal to, if we apply shift one time, I will show you, if we apply shift one time we get f of x. If we will apply it 1 by 2, so it will be this will be f of x plus, and here comes, if it is applied n times it will be n times h, if it is applied 1 by 2 times it will be this one, and this is the inverse. If we go in the negative direction then it will be minus. If we say, if we apply here, you can do it as such, you can, if here is minus, so here will be minus. So this is inverse shift operator. If here is minus, so only it will go in the backward direction, rather than going in the forward direction it will go in the backward direction. So this formula can be written something like this one. So this is a central difference operator. Okay, now we will move forward. Next is average operator. Now we shall study what is average. Average is means sum of two numbers and then divided by 2. That is the definition of average. So we will see whether something like that is being used somewhere here in this context. So we will be trying to just see whether this definition of average is being utilized in this average operator definition. We will see it is denoted by mu. This is denoted by mu, and the formula for average operator is given by, now see here 1 by 2 is sum of two numbers and here is 1 by 2. Now once again this is in center and average of two numbers again is taken. This is f of x plus h by 2, this is x minus h by 2, their sum divided by 2, and again in the shift operator notation this can be written something like that. So this operator is known as average operator. So once again, why it is average? Because it is in between these two numbers. Okay, fine. So the average is taken. In the central operator we had taken the difference. Okay, fine, there was no divided by 2, because in average it is by definition, implicitly it is by definition that it is divided by 2. So now next we will move towards the differential operator, and it is denoted by capital D, and formula for differential operator is something like dfx is equal to dy dx, fx is equal to f dash x. So this is known as a differential operator. So whenever in formula the capital D is used, so that means the differentiation with respect to the variable, the independent variable involved in the given question. So D is equivalent to dy dx. So far we have studied these operators. This one is forward difference operator, this one is backward difference operator, this one is shift operator, and this is delta is central difference operator, this is average operator, and this is differential operator. So far we have studied the definition and we have understood the meaning of these 6 quantities. What does these 6 quantity means? What is interpolation? We have studied. So in the next lecture we will be studying what is the relation between these 6 quantities. So that is very important from the examination point of view. But before concluding, I will revise the definition of all the six operators studied so far. So now let me revise the definition of the operators studied so far. So forward difference operator, this is denoted by delta, and this is f of x is equal to f of x plus h minus f of x. Difference means there is difference between the two numbers, and forward means it is in the forward direction, and it is, since it is in the forward direction, so it is taken first. So this is the definition of forward difference operator, and this is illustrated by this figure. So this is the definition of forward difference operator. Now what is backward difference operator? Backward difference operator is denoted by nabla, or it is also known as del. So this del fx is equal to f of x minus f of x minus h. This is x and this is in the backward direction, this is x minus h. So this is the backward direction, therefore it is called f of x minus f of x minus h. This is called the backward difference operator. Now next is shift operator. Shift, as the name indicate, shifting from x to the next adjacent value in the forward direction, and the next forward value is x plus h. So when e applies n times, it shifts in the forward direction n steps. When it is applied one times, it shift in the forward direction n one times only. So this is x plus h. So now central means something about the center. So difference means difference between the two numbers, and it is denoted by small delta. Formula of central operator is this one. This is the formula for central operator. The delta f of x is equal to f of x minus f of x plus h by 2 minus f of x minus h by 2. So this is the central difference operator. Why central? Because now see, this is center, okay, fine, and this is x minus h by 2, this is x plus h, in between 1 and h, this is h by 2. So this is the difference between these two quantities. These two quantities are in the center. These x1, x minus h, x plus h, these values are given, but these values are in center between the two values, and difference between them is called central difference operator. So now see the name central. Central means this is the value, this is the value given, but it is in between the two values, this is also in between the two values, so this is in the center, and difference between them is the central difference operator, and it is denoted by nothing but small delta. So then you should try to pick the definition from its name. Average operator, as the name indicates, average is the sum of the two numbers divided by 2. So it is denoted by mu, and here is sum of two numbers. Central, again it will be used in central sense, in between these two, this one. Average of two central numbers, like this one, f of x minus h by 2 plus f of x plus h by 2, their sum divided by 2. In the shift operator notation, it could be written something like that, and I have discussed it in the start of the lecture, in the beginning. Now differential operator D. The differential operator is nothing but the d by dx. Simple differentiation is denoted by capital D. Capital D denotes operator. Of which operator? D by dx, differential operator. Okay, fine. So this is differential operator. So that is how we have studied the definition of 6 operators. This will be studying in the next lecture. So these 6 operators we have studied. So in the next lecture we'll be studying between the relation between them, so till then you just go through the definition of these operators and try to understand the meaning, try to grasp the idea, and very soon I will be with you with a new video lecture that will be illustrating the relation between these 6 operators, and that relation is very important from the examination point of view, and there is hardly any time when a question is not seen from the that portion that is concerning the relation between these 6 operators. So till then, take care, bye bye, see you soon. This is Dr. Rajesh saying you take care, bye bye.